This question 21, you have a Boltzmann distribution, a graph showing you the energies of all molecules in a reaction, right? That is why you have the proportion of molecules of a given energy. Here will be energy. So every molecule, their energy is its energy is recorded here. So usually, just like in one class of students, you will have a few students who always have lower energy. Okay, after a few concepts, okay, need to rest for a while. Okay, some very hyper. Okay, you see them always walking around. Okay, so from lowest, okay, to highest energy, but definitely there will be zero molecule, okay, with zero energy. Definitely will have some amount of energy. Okay, now this is for T1. If we increase the temperature, what will happen is, okay, all molecules will gain slightly more energy from, okay, from the heat that is provided. So the graph will definitely shift, okay, to the left and lower. Okay, why must be lower now? Okay, because most of these molecules with average amount of energy just now, okay, now move to the right hand side. So appear to be lower, okay, but actually the proportion here is higher. Okay, so T2 go to the shift to the right hand side, okay, with lower peak. And then question say there's a catalyst that is being used also. So you know catalyst will provide a pathway with lower activation energy. Here, okay, not catalyzed, uncatalyzed. So catalyzed one will be here, the EA, lower than the one without catalyst. So look for the answer that matches, okay, what I've just drawn using the red ink. Okay, T2, T2, okay, C or D. Now let's check the activation energy. Okay, catalyzed one lower than uncatalyzed. So the answer is C. Question 22 is about an element T in period 3. Okay, it's saying that the first ionization energy of T is lower than the element with one less proton. Okay, one less proton means the element on the left-hand side in the periodic table. And I think the second clue is better. The oxide of T does not react with water. You only know two oxides that don't react with water in period 3. Aluminium oxide, okay, and silicon dioxide, right? These two. So T is aluminium or silicon, both also in the answers. You have to look at, okay, you have to actually look at the first ionization energy. So I actually copy this from the notes. 13 will be aluminium. Okay, 14 is silicon. So it says the first one, okay, the first clue given to us is the first ionization energy of T is lower than that of the element with one less proton. So the first ionization energy is lower than the element on the left. Okay, for aluminium, yes, that statement is correct. For silicon, okay, it is higher than the element with one proton less, right? So the answer is A. So only two groups, right? Their first ionization energy will be lower than the element on the left. They'll be group 13 and group 16 only, yeah? Okay, so only remember these two groups. If you want the element, it should be aluminium and sulfur, or okay, the elements above these two in the same group. Because in AS syllabus, they only focus on period 2 and 3. Okay, they don't go to period 4, 5, 6. Unless it's an application one, but usually I see them only asking for the elements in period 2 and period 3. Question 23. You're given 3 metals. They are side by side in period 3. Sodium in group 1, magnesium group 2. Okay, group 1, group 2, this one group 3. You're given the melting point. Okay, then which factor explains the increase in melting point? So they only want you to explain why, okay, the melting points are increasing. So for metals, when you talk about melting points, you look at the metallic bonding. Because in metals, the intermolecular forces is, okay, the intramolecular forces, which is metallic bonding. Okay. Metallic bonding is affected, the strength of metallic bonding is affected by two factors. One is the number of valence electrons that each atom, okay, can be contributed to the sea of delocalized electrons per atom. Okay, number of valence electrons, okay, per atom. That's factor number one. Factor number two will be the number of, sorry, no, the charge, okay, on the cation ion. So group 1 sodium, in group 1, 1 valence electrons, okay, and it will form a +1 charge cation. Group 2, 2 valence electrons, okay, and +2 cations. Aluminium group 13, so 3 valence electrons and +3 charge cation. So more electrons and higher the charge, stronger is the metallic bonding. That is why the melting point will increase, okay, if these two factors are higher. So we look at the factors, the change in the first ionization energy, no, the increase in electronegativity, the increase in atomic weight, and the increase in number of outer electrons in each atom from sodium to aluminium. Okay, only D is talking about one of the factors, the number of outer electrons, number of valence electrons. Okay, so the answer is D. The answer is B. I remember the answer is B. Okay, 6 products will actually have ketone functional group. So if you can remember the answer, okay, please remember this answer until the actual exam. I don't know whether this question will come out again or not because it is repeated, I think, at least twice already. Okay, so of course now we have to go to question and explain to you why. For those who cannot remember, why 6 molecules. Okay, you have this whole molecule reacting with hot concentrated acidified okay, that would be alkene reacting, okay, with this hot concentrated acidified KMnO4. But of course, if there is OH alcohol, primary and secondary alcohol and other functional groups that can be oxidized, they will also react. Okay, but if you look at this beta carotene, it contains only a lot of alkene functional groups. Okay, one here, okay, another one, total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 11 alkene functional groups. So all of them will react with this reagent. Okay, and how they react, they will be broken. Okay, yeah? Broken. Okay. Now, usually when you see double bond, they are only broken, usually only the pi bond will be broken, but this hot concentrated acidified KMnO4, the conditions are too extreme, yeah. Not only acidified KMnO4, because acidified KMnO4 is already a very strong oxidizing agent. Now, we are using hot and concentrated one. We increase the power of this oxidizing agent, so even the sigma bond will be broken. Okay, so here, this one whole thing, okay, first molecule, second, okay, third, fourth, okay, fifth, sixth, seven, okay, eight, nine, and 10. Okay, reacting with this hot concentrated acidified KMnO4, beta carotene will give you 10 molecules of products. Now we are supposed to check which one contain ketone functional group, which product, yeah? So we look at the first one, okay? The first molecule, this part is also broken, yeah. But because it was in cyclic structure, so when this part is broken, okay, they are still all connected to each other. So you only get one molecule. Hold on, let me see if I can copy this to another slide. Hold on, I need to cover this whole part. Give myself more space to draw. Okay. Right. Number one, yeah. Let me change the ink also. Okay. I want to number all the carbon in molecule 1. Okay, start from here. Carbon number 1, 2, 3, 4, 5, 6, 7. Okay. Wait, 7 here, 8. Okay, now all the side group 9 and 10. Okay, 10 carbon. So I'm going to start with carbon number 1. Here, this one, this carbon. Okay. Double bond. Okay, wait, remember when alkene reacts with hot concentrated acidified KMnO4, okay, that double bond part broken, right? Then you have to add an O because it's oxidized. Okay, then bonded to carbon number 2 here. Okay, double bond, another O, bonded to carbon number 3. Okay, carbon number 3 is bonded to carbon 9 and 10, the 2CH3 group. Okay, go to carbon number 4 now. Sorry, number 1, 2, 3. This is 9, 10. Carbon number 4, you have the CH2, no change, yeah, CH2. Number 5, CH2. Okay, number 6, another CH2. 7, a double bond again. Yeah, broken, so at double bond. And then bonded to carbon number 8. Okay, sorry, my tablet, when it goes to very close to the edge, it become like that. Okay, number 7, number 8. Okay, now, okay, you see, this carbon number 1, this C, okay, double bond. So only 3 bonds. One more bond, okay, you need to add OH. So if you can remember the reaction between alkene and also hot concentrated acidified KMnO4, okay, we cannot see any hydrogen bonded to carbon, right? Okay, they are all oxidized, so you add an O, okay, and then if there's a H, you need to change it to OH. So this will become OH. So here, okay, becomes COOH. Number 2, already 4 bonds, so C double bond O only. 7, okay, 4 bonds also, so no more OH. So we look at this product number 1. Does it contain ketone functional group? Okay, the answer is yes. Can you see this carbon number 7 is a ketone? Okay, and actually carbon number 2 is also a ketone. Okay, so let me put tick for carbon product number 1. It contains a ketone. So later you need to count how many products contain a ketone functional group. So let us look at product number 2. Okay, product number 2. I'll probably change another color. Okay, product number 2, again, I number the carbon. Okay, 1, okay, 2, and then 3. Only 3 carbon in product number 2. Carbon number 1, double bond, so please add oxygen. Go up, bonded to carbon number 2. Okay, left hand side, carbon number 3. Now, carbon number 3 has a double bond. So add oxygen. So let us count. They must all have 4 bonds. Okay, all carbon, yeah. 1, 2, 3, 4. Okay, done with the carbon number 1. Carbon number 3, 1, 2, 3, 3 bonds only. So add 1 more. Okay, and it becomes OH because there's H here. Remember, no more H, yeah. When you see an H, okay, you have to change it to OH. So product number 2, does it contain a ketone functional group? Yes. Can you see carbon number 1 is a C double bond O, left hand side, right hand side, R groups. So there's a ketone. Okay. Now, before I move on to product number 3, I just want to show you that product number 4 is the same as product number 2. Can you see it contains 1 carbon, 2 carbon, okay, 3 carbon. Okay, this is a side chain, alkyl group, here alkyl group. Okay, left hand side you have a double bond. Okay, here also double bond. So 2 and 4 are the same thing. Okay, we'll give you the same product and okay, also will contain a ketone functional group. So let's put a tick first. So now let's check through all the other products. Are they the same as 2 and 4? Okay, 5 not the same because there's no CH3 here. 6 not the same, no CH3. 7 again. Side group, 3 carbon, 1, 2, 3. Okay, there's an alkyl group. So 7 is again the same as 2 and 4 and contains a ketone functional group. Number 9 also the same. Okay, so 2, 4, 7, 9, they are the same. They contain a ketone functional group. So now, so far, we have already ticked 1, 2, 3, 4, 5. Okay, 5 molecules. Okay. Now, can you see that this number 3? Okay, number 3, number 5. Okay, number 3, 2 carbon, yeah. Number 5 also 2 carbon, no branch. 6, 2 carbon, no branch. Okay, 8, 2 carbon, no branch. Okay, so they all again will give you the same type of product. So if 2 carbon, carbon number 1, carbon number 2, okay, double bond O, double bond O. Then OH, OH. Okay, any ketone functional group, no ketone functional group. Okay, you have carboxylic acid functional group. Both carbon also carboxylic acid functional group. So no ketone. Okay, number 3 no ketone, number 5 no ketone, number 6 no ketone, number 8 also no ketone. Let's look at the last one, number 10. Okay, if you can see number 1 and number 10, okay, same type of product. How? Okay, let me number the carbon. 1, 2, okay, 3 bonded to 9 and 10. Okay, 4, 5, 6, 7, 8, okay, 9, 10. See number 1 here, same as number 1 on the left, product number 1. Okay, number 2, double bond here. Number 3 bonded to 9 and 10, alkyl groups. Okay, number 4, number 5, 6, 7 with double bond. It bonded to alkyl group number 8. Okay, then go back to number 2 again. So product number 1 and number 10, they are the same and also contains a ketone functional group. So now let us count, okay, how many product molecules okay, contain a ketone functional group? 1, 2, 3, 4, 5, and 6. 6 product molecules contain, okay, a ketone functional group. That is why the answer is B. Yeah. So again, if you see this question in the actual exam, okay, automatically circle B or 6 as the answer. I shown you how to come up with this working. You understood the working already. So now you know why, okay, 6. So if you see this question again, okay, the answer is 6. Question 25 is a question about the solubility of group 2 hydroxides and group 2 sulfates. So before we start, let's just write down the trend. Yeah, group 2 hydroxides. Okay, let's start with magnesium hydroxide, calcium hydroxide, strontium hydroxide, and then barium hydroxide. Here, group 2 sulfates, magnesium sulfate, calcium sulfate, strontium sulfate, and barium sulfate. Now, solubility going down the group, okay, increases for hydroxide. Okay, for sulfate, the solubility will decrease. Solubility, yeah. Solubility. Okay, now knowing these two trends already, we can now start looking at the question. You have W, X, Y, Z, 4 test tubes. Okay, the first two, barium chloride, magnesium chloride. Then the last two repeat barium chloride, magnesium chloride. Why they do like this? Because to the first two, they want to add sodium hydroxide. Okay, the last two, they want to add H2SO4. So when sodium hydroxide is added to the first two, in W test tube, you get barium hydroxide as the product. Okay, Ba2 plus reacts with the hydroxide ions, you get barium hydroxide. A second test tube, magnesium 2 ions will react with hydroxide ions, you get magnesium hydroxide. So two hydroxides are formed. Okay, they are asking you which one has a higher pH. Yeah, which one has higher pH? Solubility of hydroxide going down group 2, okay, increases. So barium hydroxide is more soluble. More soluble, more hydroxide ions, higher the pH. Yeah, this one higher pH. Magnesium hydroxide, lower solubility, less hydroxide ions in the solution, so lower pH. Now, both pHs are still more than 7 because they are both basic hydroxide ions, right? But barium hydroxide is more soluble, so a higher concentration of hydroxide ion will contribute to higher pH. Then the other two, okay, the other two test tubes, we are going to add sulfuric acid so that they form sulfates. Yeah, and then we are supposed to see which one has a greater mass of precipitate. So again, it's about solubility. Sulfuric acid added to a test tube Y, you get barium sulfate. Added to test tube Z, you get magnesium sulfate. So which one is more soluble? Magnesium sulfate is more soluble. Barium sulfate is less soluble. This one less soluble, okay. This one less soluble. So more soluble. So this is Y. Okay, this one is Z. The one that is less soluble, okay, will give you more precipitate because they stay as solid in the solution, right? So Y will have, okay, a greater mass of precipitate, and W is the one with higher pH. So the answer is A. Question 26 you have nitrates of beryllium, calcium, magnesium, strontium. They are all group 2, yeah. Okay. Since they are all group 2 metal, so we can write a general formula, general equation for the decomposition of these nitrates. Okay. M to represent metal from group 2, nitrate, sorry, magnesium, NO32, you get MO, think 2. Okay. You get NO2, 4, and then you get 1 oxygen. Now, this is the equation that you need to remember because I realized that they like to give the composition of nitrates of group 2 in paper 1. Paper 2 somehow, its popularity has decreased. It came out, okay, it comes out less in paper 2, but paper 1, because they can create a lot of very tricky calculation questions from this decomposition of nitrates. Okay, so you need to remember this equation. Okay, 2241. Okay, now it says that when 2 grams, okay, 2 grams of the metal nitrate, okay, is decomposed, 1.32 gram of gas is produced. Now there are 2 gases here. So this 1.32 is the total mass of these 2 gases. So because of that, they combine the gases. Okay, I think you should also combine these 2 gases, okay, in your calculation. Then that will make your life easier. Or, okay, what can you do is another easier method, 2 minus 1.32, so that you get the mass of the magnesium oxide. Okay, 2 grams decomposed, you get 1.32 grams of gases. So that means the remaining will be the oxide. 2 minus 1.32. Sorry. 2 minus 1.32. Okay. 0.68 gram will be the metal oxide. Okay. Now, the number of mole from the equation, you know that the number of mole of the nitrates, okay, the metal nitrate, yeah, I just simplify it because if I write the whole formula, then it'll be too many brackets. It's the same as number of mole of the magnesium, so the metal oxide. Yeah, because 2 to 2, so that means 1 to 1. Ratio is 1 to 1. So they have the same number of mole. Okay. So 2 grams, number of mole is found by the mass of solid divided by the MR of the nitrate. Yeah, MR of nitrate. This is 0.68 gram divided by the MR of the oxide. Okay, so 2 divided by atomic mass of M, AR. Okay, 2 nitrogen, so 14 times 2, 28. Oxygen, you have 3 times 2, 6. 16 times 6. It will be equal to 0.68 divided by metal oxide, right? So AR, the atomic mass of the metal, and also oxygen, 16. So by rearranging everything, you will be able to get 2AR plus 32, 0.68 AR plus, need calculator, 16 times 6 plus 28, 124 times 0.68, 84.32. So 2 minus 0.68, okay, 1.32 AR equals to 84.32 minus 32. 52.32, so AR is 39.6. okay, or it's very close to 40. Now let us look at the periodic table and see which group 2 metal has, okay, a relative atomic mass of 40 or around 40, yeah. Okay. Group 2, 9, 34.3, 40.1, 87.6. We only given these 4, right? So calcium is the one with the closest, okay, atomic mass that I've calculated here. So the answer is B. Question 27 is about a compound Q. Compound Q is a white crystalline solid which dissolves easily in water. Okay, silver chloride cannot dissolve in water, right? Cross out. Okay, sodium bromide, okay, dissolve in water. Sodium compound always dissolve in water easily. Okay, this one is another soluble solid. Now let two bromide, okay, let two compounds are usually not soluble in water, but again, okay, this is because I know if I don't, it's okay. Then you just don't cross it out, you leave it there. Then you can read the second line. Now, when concentrated sulfuric acid is added to dry sample of Q, steamy white film are formed. Okay, steamy white film form. HBr is steamy white film, HCl is steamy white film. If you don't know this one, you think HBr is steamy white. Okay, second line useless. Then when passed through aqueous silver nitrate solution forms a white precipitate. Oh, with silver nitrate forms white precipitate. So white precipitate must be silver chloride. So the halogen must be chlorine. So look at this B and D. Okay, both also bromide or bromine. So they won't form white precipitate with silver nitrate. Now I got my answer. The answer is C. Unless you cannot remember, okay, what precipitate is silver chloride, okay, you don't know, it must be because of chlorine. You have to go through the last one. This precipitate is soluble in direct ammonia solution. Then you're like, oh, now I remember it's silver chloride because it dissolves, okay, it is soluble in ammonia solution. So can you see the difference between people who can get the answer here, okay, and the people who can only get the answer until the last line. Okay, it's about how many seconds you can save compared to other people. Okay, question 28 is another, it's about another compound Q again. Now Q in this question, okay, is representing an atom of chlorine, bromine, and or iodine. One atom only. Okay, halogen atom. And then now they're asking you to explain the variation in the volatility down group 17. Volatility means how easily they can turn into vapor. Ease of turning into a vapor. Okay. In simple terms, how fast they can become gas. Okay, or how easily they can become gas. Less energy to become gas, very volatile. So volatility is about becoming gas. So you are overcoming the intermolecular forces. Yeah, because become gas means we're talking about boiling point. Whenever you need to talk about boiling point, okay, you have to think of the intermolecular forces. So if Q, okay, is chlorine, bromine, okay, or iodine, okay, volatility, okay, Cl2, Br2 and I2, you talk about the intermolecular forces between these molecules. They are all non-polar molecules. So there's only one type of intermolecular forces, ID, instantaneous dipole, induced dipole forces. You can use ID, okay, for instantaneous dipole and induced dipole in your paper too. So don't have to write the full name. They accept ID. Okay, so that will save your time. So how easily they become gas? Okay, as long as you overcome the ideal forces between the molecules, they become a gas. So answer is A because I only see ID forces in A. Let's just go through. ID forces between the molecules become stronger. Okay, because going down group 17, you have chlorine gas, okay, you have bromine liquid, and then you have iodine solid under standard conditions. At room conditions, one is a gas, the other one is a liquid, another one is a solid. So going down the group, can you see that, okay, it's getting harder and harder to become gas. Chlorine is a gas at room temperature, but that means, okay, its boiling point is below room temperature. So it becomes gas very easily. Okay, bromine is a liquid, that means you still need to provide heat so that it will become gas. Iodine although can sublime to gas, but again, you still need to provide heat energy. Okay, it's harder to turn solid into a gas compared to liquid to a gas, yeah? So going down a group, because iodine forces are getting stronger, that is why, okay, harder to become gas. Cannot be permanent dipole forces. Okay, B is not correct because they are non-polar molecules. They don't have PD forces. C, the bond energy, we are not talking about breaking their bond so that they can react with another reactant. Okay, we are talking about between the molecules only. Okay, because we only want to change the physical state. So not the bond energy. And D, the first ionization energy, again, there no reaction here. Okay, only physical changes. So we don't have to talk about the electrons. Okay, not how easily they lose electrons. Therefore, the answer to this question is A. 29. Photochemical smoke is a type of air pollution produced in urban areas by the effect of sunlight and on substances released from vehicle exhaust. Which mixture of primary pollutants leads to the formation of photochemical smoke? Okay, this is new in the syllabus. Everything that is new in the syllabus, they have higher tendency to come out in the exam paper. So focus on this part, yeah. Photochemical smoke here. You see the, the very hazy, not foggy, okay, the haze, okay. If one day you wake up, then you go to KL, you see haze, that means that is photochemical smoke. You have something that react with each other and then form that very fine particles suspended in the air, okay, and that compound is actually this. It is peroxyacetyl nitrate, short form PAN. Okay. If they ask you to write the formula, it is CH3COOO and O2. Yeah, zoom in, make it bigger so they can see better. This one, CH3CO3 and O2. Structure looks like this: CH3, C double bond O, single bond O, single bond O, and O2. Now, how is this formed? A reaction between nitrogen oxide, okay, nitrogen monoxide or nitrogen dioxide with unburned hydrocarbon. So again, nitrogen monoxide, okay, and nitrogen dioxide, or you can generally call it nitrogen oxides, okay, react with unburned hydrocarbon in sunlight, then it will form PAN, peroxyacetyl nitrate. Okay, this is the formula. Now, go back to the question, yeah. Which mixture leads to this formation of photochemical smoke? So you see, so nitrogen oxide and unburned hydrocarbon. So the answer is C. For question 30, a compound R, okay, it is a solid. All these are solid, so I cannot rule out any answer because of the first line. Second sentence, R, yeah, R fizzes when hydrochloric acid is added. You add acid to a solid, okay, then you see fizzing, effervescence, right? It is a carbonate. So rule out this one. Sulfate will not, okay, will not give fizzing, no effervescence between sulfate and acid. So all this has carbonate. Okay, good. So R is A, B, or C. Now, R reacts with hot aqueous sodium hydroxide, giving off a gas which turns red litmus blue. Yeah, reacts with hot aqueous sodium hydroxide, giving off a gas which turns red litmus blue. A gas that will turn red litmus blue must be NH3, ammonia. Okay, this one you see in paper 3 also. Okay, ammonia turn red litmus blue. And then what can react with sodium hydroxide to give out ammonia? It must be ammonium compound. So just now you found that this is carbonate. Now you found here ammonium. So the compound is ammonium carbonate. Okay, now you see, yeah, I tick C also because it could be hydrogen carbonate here. Hydrogen carbonate reacts, behaves the same like carbonate, okay, when it comes to reaction with acid. So hydrogen carbonate can also be the answer. Okay, so if you have ammonium carbonate, ammonium positive 1 charge, carbonate 2 negative, right? So that means you need 2 ammonium ion, 1 carbonate ion in the formula. Okay, so B could be correct. So let's circle first. A is definitely wrong because this formula is not correct. You need 2 ammonium to balance the charge on the N ion. Now, hydrogen carbonate has negative 1 charge. So ammonium, okay, positive 1, hydrogen carbonate, negative 1. So you need only 1 ammonium to balance the charge of the hydrogen carbonate. So this 2 is not correct. C is also not correct. So the answer to this question is B. Question 31, skeletal formula of compound X is shown here. What's the molecular formula of compound X? Okay, finally, an easier question. Molecular formula means just count all the number of all atoms of different elements. Okay, so carbon first. 1, 2, 3, 4, 5, 6, 7, 8. I always count the one in the backbone first, yeah. The longest chain. Okay, 8 carbon. Now the branches, 9 carbon, 10. Okay, C10. C10, C10. Wrong, wrong. Okay. What other elements? Oxygen. There's 1 oxygen here. Okay, only 1 oxygen. 1 O, 1 O. Okay, cannot rule out. Now last one will be hydrogen. 1, 2, 3. No hydrogen here. 4. Okay. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 hydrogen. So the answer is A. There's a compound Y here. It has this structure, and you are supposed to first answer which type of carbonyl group, aldehyde or ketone. Okay, and then how many chiral centers are there in one molecule of Y? So first, the carbonyl compound, the C double bond O, they bonded to one R group, and the other R group, there's no CHO. Okay, the CO is not bonded to hydrogen, so this is a ketone. So there's only 0 or 1 chiral center. Carbon that is that has double bond, okay, not a chiral center. Carbon that is bonded to 2 hydrogen, 3 hydrogen, not chiral center. So that only leave us to 1 carbon to check. Okay, so this carbon is bonded to one group. There's another H here, so 2 different groups. Now the other groups, they are all in a cyclic structure, so we need to check the symmetry of the molecule. Yeah, so go through this carbon, half the structure, left and right. There's a double bond here, but no double bond. So yes, this carbon, okay, is a chiral center. There's 1 chiral center. So the answer is D. Question 33. two students each make a statement about 2-methyl-but-1-ene. Okay, let's draw the structure of 2-methyl-but-1-ene first. We'll definitely need the structure now. 2-methyl-but-1-ene means 4 carbon. Okay, but means 4 carbon, yeah. 1-ene, that means the double bond is between carbon 1 and 2. We take a smaller number, right? That is why but-1-ene. The alkyl group, the methyl group is carbon number 2, CH3. The rest are all hydrogen. Okay, that is the structure of 2-methyl-but-1-ene. Okay, student 1 states that 2-methyl-but-1-ene has geometrical isomers. So focus on the 2 carbon, okay, sharing a double bond. These, okay, and this. Now, each of them must be bonded to 2 different groups of atoms. Then only 2-methyl-but-1-ene has geometrical isomer, cis-trans isomer, right? So carbon on the left bonded to 2 hydrogen. Okay, same type of atoms. Carbon number on the right hand side, yeah, it's bonded to 2, but both carbon must be bonded to 2 different groups of atoms, because the carbon on the left is already bonded to 2 same type of atom, hydrogen and hydrogen. So no geometrical isomer. Okay, student 1 is not correct. Student 2 states that 2-methyl-but-1-ene reacts with HBr in addition reaction to give 1-bromo-2-methyl-butane as the main product. Now, this is obviously not a symmetrical alkene. Okay, the addition reaction with HBr will give you 2 different products. Okay, one of them, the H is bonded to the carbon on the left. Okay, Br to the carbon on the right, C2H5, and there's CH3. Okay, another product will be H bonded to carbon on the right in the double bond, yeah. Br is bonded to the carbon on the left. Hold on, wrong, CH3, C2H5. Okay, 2 different products. Now, which is the main product or the major product? You use Markov-Nikols's rule, okay, to find the main product because it's paper 1, right? It reminds me of one thing. In paper 2, you are asked to explain why major product. Okay, a lot of you were still writing Markov-Nikols's rule. Now, Markov-Nikols's rule, you can only use it in paper 1. You cannot write Markov-Nikols's rule in paper 2 for explanation. Okay, for paper 2, you must talk about the stability of the carbocation ion. Okay, now Markov-Nikols's rule says that, okay, hydrogen must be a hydrogen is added to the carbon that has more hydrogen initially, right? So initially this carbon has 2 hydrogen, 1, 2. Carbon on the right, no hydrogen. We only look at hydrogen that's directly bonded to carbon, yeah. So no hydrogen directly bonded to the carbon. So this one 2 hydrogen, here 0 hydrogen. So major product will be the hydrogen bonded to the carbon with more hydrogen, which is the carbon on the left. So this is the major product. Major, this is minor. Okay, so let's name the major product. This is called 2-bromo, okay, 2-methyl-but, okay, butane, sorry, butane, okay, because no more double bond. So 2-bromo, 2-methyl-butane, okay, this is 1-bromo, okay, 2-methyl-butane. This is the minor product, not the main product. So again, student 2 is not correct. So our answer, which students are correct? Okay, neither 1 nor 2. The answer is D. Question 34 is a polymerization question. You have 2 monomers, different monomers, and form a polymer. So you're supposed to find which monomer can form the polymer that is given here. First, okay, there is still a double bond in the polymer, and that double bond is not the side side chain type of double bond, yeah, is actually in the skeleton, okay, the skeleton of the backbone of the polymer. So that means one of the monomers, okay, this part, this one is from a monomer which has two double bonds. Okay, so something with two double bonds like this, okay, after forming polymer, the double bond goes to the middle. Yeah, like this. Because why? Each electron has to go to left and right hand side, okay, to form the polymer. So two more go to the middle and form a pi bond, right? So monomer has two double bond. At the end, you still have one in the polymer. And that one double bond in the polymer is in the backbone, not the side chain. If you see the double bond in the branch, okay, then it should also be from the branch in the monomer. But this is not from the branch, it is in the skeleton, right? So that means the monomer has two double bonds. Now, in order for the monomer to have two double bonds, okay, two double bonds, it must have a minimum of 4 carbon like this. Okay, because the two double bond won't be side by side. Okay, it's double bond, single bond, double bond, single bond. So minimum 4 carbon, which is why, okay, I can immediately circle these 4 carbon and know that they are from the same monomer. Okay, so the other 2 carbon here from the other monomer. Okay, now let's look at the answers. So one monomer, 2 carbon, the other monomer 4 carbon. Okay, 2 here, not this pair. Okay, 2 here, 4 could be B. Okay, keep in view. C, 2 carbon, and then 4 carbon. But you see, this one only 1 double bond. I want 2 double bonds right in the monomer. So this is not correct. And the last one, D, 4 carbon, 2 carbon. Okay, again, the 4 carbon has only 1 double bond, so not this answer. So our answer is B. Okay, but of course we check, yeah. So CC, okay, H2HCl, okay, CH2, CHCl, correct. Now in polymer, the double bond is gone because it's opened up to form the polymer, so no more double bond in the middle. Okay, pi bond is broken, we are left with sigma bond only. That's why the single bond here. Right hand side, 4 carbon, the monomer with 2 double bonds. Okay, breaking of pi bond, and then each electron from the pi bond now go to the middle and form a new pi bond here. Okay, the rest all single bond. Okay, that is why B is the correct answer. Yeah, so to solve this question, first you check, okay, whether the polymer has a double bond or not. Okay, and where is the double bond? If the double bond, okay, is here in the longer chain of this polymer, not the branch, that means one of the monomers, okay, will have 2 double bonds. Okay, and to have 2 double bonds, that monomer must have minimum of 4 carbon, like this. Question 35, a student converts 1 iodo-propane, this is 1 iodo-propane, into butanoic acid, this is butanoic acid, C3H7I to, okay, to C3H7CO2H. Why do I leave an empty space here? Because it says it's a 2-stage chemical synthesis. 2-stage, okay? 2-stage. So first stage will convert 1 iodo-propane to something first. Then that something is converted to butanoic acid. Yeah. Now, usually 2-stage chemical synthesis like this, the first thing that I will do is I count the number of carbon. Okay? Because I realized that 2 stages type of chemical synthesis, they really like to give you at least 1 extra carbon in the middle. Okay, 1 extra carbon from the first one to the intermediate. So You see, here 3 carbon. Okay, no more carbon at the back, so 3 carbon. Last one, okay, the butanoic acid, 3 carbon here, 1 more carbon here, total 4 carbon. So how do I get extra 1 carbon? Okay, that means one of the stages must be involving a cyanide, okay, a cyanide ion being added or being or substituted something from the beginning. Okay, 3 to 4. So I need to add 1 more carbon. So I need a potassium cyanide or hydrogen cyanide. Okay, but I'm looking at halogenyl alkane. Halogenyl alkane will only react with ethanolic potassium cyanide or ethanolic sodium cyanide, not hydrogen cyanide. Hydrogen cyanide with the KCN, okay, is only for aldehyde and ketone. Okay, so but of course we still check if I add KCN, okay, in ethanol, what do I get in the middle? C3H7CN. Now, can I convert this nitrile to butanoic acid or not? Okay. Yes, okay, nitrile can be hydrolyzed to carboxylic acid. We can use acid, okay. Hydrolysis, we use acid, right? Acid and heat. Aqueous dilute acid solution, and then heat, we will get butanoic acid. Okay, so confirm that our answer is cyanide. Let's say you're unsure, you feel very insecure, what can you do is very time consuming, but you can test one by one. Worst case scenario, you cannot remember how to solve this at all. Okay, you still have your last resort. Okay, try and error, try every single answer one by one and see, okay, they can reach butanoic acid or not from 1-iodopropane. Question 36. Which statement is correct when referring to the complete combustion of PVC? PVC is polyvinyl chloride. Okay, sorry, wrong spelling, chloride. Okay, PVC. Most important thing is it contains a chloride. Yeah, it contains chloride in the polymer. So when you do combustion of any polymer which contains carbon, hydrogen, chloride, what can be produced from the carbon will be CO2, oxidation, right? Combustion. Hydrogen will form water. So you just imagine they all react with oxygen. What is formed, right? But chloride, okay, but chloride in the combustion is not reacting with the oxygen. Okay, instead it actually reacts with the hydrogen from the water to form HCl. Okay, Cl or any other halogen atom in the combustion, because water is also produced, so you have some hydrogen ions, okay, or hydrogen atoms that can combine with these halogen atoms to form hydrogen halide, HCl, HBr, Hi. Okay, so from here you can see that acidic product is formed. Okay, acidic product is formed at the same time you have CO2 and H2O also formed. Because polymer you are making from alkene will definitely have C and H. Now let's look at all the answers. Okay, which statement is correct? A gas is made which contributes to global warming. Okay, what gas is contributing to global warming? CO2. Is there a CO2 being produced from combustion of PVC? Yes. Okay. Oh, wait, so 36 is A. Is 36 A? Okay, let's go first because it's correct. Now, B, CO2 and water are the only products. Okay, we have CO2, we have H2O, but definitely not the only products because PVC contains chlorine. Okay, HCl is also formed, right? So this only it's not correct. C, if water is used to clean the exhaust gases, the water becomes alkaline. If water is used to clean the exhaust gases, the water becomes alkaline. Oh, okay. Now, if you have PC, okay, you burn it, okay, then the water is used to clean. You have HCl, Okay, HCl is soluble in water. That water will become acidic, not alkaline. So C is not correct. D, there is no need to treat the exhaust gases as the products are non-hazardous. You have carbon dioxide, you have H2O, you have HCl, which is a strong acid. Okay, so we cannot say that it's non-hazardous at all. Okay, harmless gas, nitrogen, water, maybe carbon dioxide, we can still consider them non-hazardous, but HCl is definitely not non-hazardous. Yeah, it's hazardous because it is corrosive. So not correct. Some treatment is needed. Oh yeah, okay. Confirm. The answer is A. 37, an alcohol with the molecular formula C5H12O decolorizes warm acidified potassium manganate 7. The alcohol also gives a yellow precipitate with alkaline aqueous iodine. What could be the identity of the alcohol? A, B, C, D. I have to draw the structure of all these answer. This question cannot save time. A, 2-methyl butan, 2-all, 4-carbon. Okay, just make sure that we draw it very quickly. CH2, CH3OH, okay, H3, H2, H3. B, 1, 2, 3, 4, butan 2 all again, 3 methyl CH3, H here, CH3, H, CH3. C, sorry, there of space. So C here, 1, 2, 3, 4, 5. Pentan 1 all, that means 5-carbon. And last one, pentan 3 or 1, 2, 3, 4, 5. 1, 2, 3, OH is here. The rest will be CH3, CH2, CH2, CH3. There's one more H here. Okay, now can decolorize warm acidified potassium manganate 7 means it can be oxidized. Alcohol that can be oxidized must be primary or secondary alcohol. Tertiary alcohol cannot be oxidized. So let's see if there is tertiary alcohol, then we can just cross that answer. Here, tertiary alcohol. Why tertiary? This carbon that is bonded to OH is bonded to 3 alkyl groups. 3, right? So tertiary, A is not correct. B, the OH is bonded to, the carbon is bonded to R groups. Secondary, okay, B can be oxidized. C, primary alcohol can be oxidized. D is secondary alcohol can be oxidized. Next one, it gives yellow precipitate with alkaline aqueous iodine. So you must have the CH3 CHOH structure. Okay, so let's look at B. Does it have CH3 CHOH CH3 CHOH here? So can give yellow precipitate with alkaline aqueous iodine, and that yellow precipitate is triiodomethane CHI3. Right. Let's circle B first because B has this one and it can be oxidized. Check C. Does it have CH3 CHOH? No, you have CH2OH here. So C is not the answer. D, you have CHOH, but left and right, no CH3. So D is not the answer. Confirm that our answer is B. Question 38, compound Z is shown here. What is produced in good yield when the compound Z is treated with an excess of sodium carbonate solution at room temperature? Now, sodium carbonate in organic chemistry can only react with one functional group in AS. Okay, one functional group, COOH, carboxylic acid. Okay, sodium carbonate in AS libels will only react with acid. And the only acid functional group in your AS organic chemistry is carboxylic acid. So let's look at this compound and see if there is carboxylic acid functional group here, only one. You have alkene here, ester, alcohol, alcohol, alcohol. Okay, so only one functional group can react with sodium carbonate, and carboxylic acid reacts with sodium carbonate. You get COO and A. Okay, without the charges also can COO and A. And also you get CO2 and H2O. So they only show you the organic products, right? So A, COO2 and A here. The rest should be no change. No change, no change, no change. Ester, no change. Alkene, no change. Okay, A is the answer. Now let's look at why B is not correct. Because B, right, reacted alcohol with the sodium carbonate also. Not correct. Okay, cannot react. C, this part again, not correct. This is worse because carboxylic acid didn't react, right? This part is still correct. Okay, this part also wrong. Okay, here still correct. D actually make ester to react, okay, hydrolysis of ester, which is not correct, okay. Esterification can only occur when you use dilute strong acid, okay, or dilute strong base solution and heat, okay. So ester cannot react with, okay, sodium carbonate solution. That is why answer to 38 is A. Question 39, carbon is found in spearmint oil. Okay, this is a molecule of carbon here. It has ketone functional group. It has alkene functional group, another alkene functional group. So which product is formed when carbon is reacted with NaBH4? This is a reducing agent. How do I remember it is a reducing agent? I see a lot of H. Yeah. Gain hydrogen atoms. Okay, gaining hydrogen atoms is a reduction reaction. We don't learn gaining of hydrogen atoms as reduction for inorganic chemistry or physical chemistry. Remember the redox chapter, we always talk about the change in oxidation number. But actually gaining hydrogen atoms in organic chemistry will cause the oxidation number to be reduced. That is why it's a reduction reaction. So you see any reagent that is used has a lot of hydrogen. Okay, another one is LiAlH4, right? See a lot of hydrogen again, and they are reducing agent. Now, NaBH4 is only strong enough to reduce carbonyl compound. Okay, cannot reduce carboxylic acid, cannot reduce alkene, only carbonyl compounds. So this one will not react, alkene will not react, alkene will not react, only ketone will be reduced to secondary alcohol. Okay, so we are finding for answer, these two remain, but this ketone is converted to OH. So you see, this one OH, this one OH correct, this one not correct, didn't react. Alkene, not change, not change. Okay, also again, our answer is A. B, you see, alkene were reduced, so not correct. This part not correct, this one still correct. No. Okay, so the answer is A, the infrared spectrum question. Now, this question is considered one of the easier one. The reason is because maybe because it's my practice. Whenever I look at infrared spectrum, my first reaction is I see whether there is a broad peak here or not. Okay, when I say broad peak means something like this. Okay, the very high absorption one and very broad one. Why did I check this one? Because I realized that they always give me compounds with OH functional group. Yeah. So if there's a functional group that contains OH bond, like COOH, like alcohol, okay, then this broad peak will appear in the infrared spectrum. But since no broad peak on the left-hand side, the answer, okay, the organic compound that is giving this spectrum shouldn't have OH functional group. No alcohol, no carboxylic acid. Okay, now we know no alcohol, no carboxylic acid. Now let's look at A, B, C, and D. Rule out those with alcohol and carboxylic acid. Okay, here, carboxylic acid, wrong. OH, no. This one no OH, no COOH. Okay, very good. Here CH3, okay, CO, no, not alcohol, no carboxylic acid. But there's an OH here. So can you see I rule out OH only the OH bond. Okay, I rule out A, B, and D. So immediately I know the answer is C because it doesn't contain a functional group with OH bond. So always check the OH bond first. no more OH bond. Okay, if there is OH bond, then our answer must be A, B, or D, right? Okay, then only you start checking C double bond O. Okay, I start with OH. Okay, if there is OH, you have to check C double bond O. Okay, if again there is a C double bond O, okay, then you can start checking your answer. You rule out the impossible one. C double bond O and OH means COOH. Okay, but of course, you have to check the range for the data also. Okay, if this OH is not for carboxylic acid, then OH bond together with C double bond O could be a carbonyl. Okay, for at one carbon and OH in another carbon, carbonyl compound and alcohol. If the OH bond is for carboxyl group, and then you see a C double bond O bond in the infrared spectrum, that is COOH. Okay, but again, you see, only checking one OH bond will give you the answer already. So to save time, always check OH bond first.